Hey guys, welcome back to Introduction of Computer Networks at NTU. This is episode 28, and this is the last of the semester, all right? Yeah, let's see how this one goes. And as usual, for Wednesday sessions, we dig straight to the topics. And yesterday, we've introduced how inter-AS routing, BGP, runs on the internet works. You see a couple examples, one straightforward, the other slightly more complicated. And we also see in a straightforward case when an AS receives multiple AS paths. Okay, so the gateway router will select a route and then inform the internal routers through the IBGP sessions. Hey, there exists one to a particular destination, and that is how an internal router learns if there's a destination that's outside of the AS, which way to go. And that is essentially calling the intra-AS routing, potentially OSPF, to find out the next hop to that gateway router that sends the AS path to the destination X. Remember? So that is the straightforward case. Now, consider this. What if you have multiple gateway routers in a domain, and multiple gateways both receive potential AS paths to the destination that an internal router wants to send data to? Hey, then how would the internal router decide which gateway router to send the data to? An internal router does not do AS path selection. It's essentially the gateway routers doing the path selection. After the paths are selected, they are informed through IBGP to the internal routers. So all the internal router knows is that there's a path for this from this BGP gateway to the destination, and another path from this other BGP gateway to the destination. Okay, so in this next video, very important, you will see how the gateway routers does route selection first, and if they are route selected, they'll be passed into the internal routers, and how an internal router selects which gateway router to send data to, such that the gateway router can work on behalf of the entire AS and apply the AS path selected to pass the data eventually to the destination outside of the AS. So this video, as you can hear, is a little bit long, but it's very critical, almost 6 minutes. All right, let's pay attention because quiz 49 is coming right after this video. Route selection. Now, this mechanism is necessary for slightly more complicated scenarios. Let's go back to example 2 again. Right? We have this router, 1C, being the gateway router of AS1. So you see towards the end of the scenario, AS1 discovers 2 AS paths, one from AS3 to go to destination X, the other from AS2, and then via AS3 to go to destination X. So in the previous slide, we say the policy of AS1 is such that we only select this to import. And so 1C propagates this AS pass to all internal routers. Internal routers will then send packets, destination being X, through 1C and therefore being forwarded to AS3. Very simple. But what if we relax the import policy a little bit further so that 1C here cannot discard this other AS pass? As a result, 1C will need to propagate both paths internally. So each of these routers internally will see more than one routes to the destination X. Ouch. Yeah, so that's when we apply the route selection. So internal router there will need to apply route selection here to decide which of these two it will send packets to. The process is like this. Step number 1, check the local preference of these routes. So if you recall earlier, a route is what? Composed of the destination network's prefix and a set of these attributes. So we know that AS pass is one attribute. Next hop is one attribute. There's one more attribute called the local preference. So this one actually weighs the highest. So BGP actually checks the local preference first and take the path with the highest local preference. So local preference there is usually to indicate, between the two neighboring ASs, AS3 versus AS2, does AS1 prefer forwarding packets to AS3 or AS2? So if AS3 is preferred, AS3's path, so this guy here is going to carry a higher local preference. Now, if there's no local preference specified, then we go to step 2. So the internal router, let's say 1D here, will then check which of these multiple paths to destination X give us the shortest AS path. So in the scenario, 1D is going to pick this one. Now, if both AS paths have the same path lengths, then we go to step 3. We pick the closest next hop router. 1D here sees 2 paths. The next hop router for this path is going to be 1C. The next hop router for this path here is going to be 1C as well, because 1C is the border router receiving these advertisements. But if you consider a slightly different scenario, so again, we have AS3, AS2, and AS1. So the router now in the limma is now 2D. 2D here actually sees 2 AS paths. One AS path is actually coming from 2C. 2C is the gateway router connecting to AS3, which it receives a path to X, AS3, X. 2A is the gateway router connecting to AS1, where AS1 is passing another AS path to AS2. That is AS1, AS3, and X. So 2A pass this path to 2D. 2C also pass on this path to 2D. So 2D in the end learns, there's one AS path through next hop to A, this guy. There's another AS path through 2C, this one. 2D here, assuming that abandon the shortest AS path phase, go straight to the closest next hop router phase. Then we'll do this. For this path, next hop router is 2A. For this path, next hop router is 2C. 2D here will consult the intra-AS routing again to find out, is 2A closer or 2C being closer? So if you see the scenario, 2A distance to 2D is only the link cost between 2A to D, which is 201. Distance between 2D to C, however, is 263. So 2D here is going to choose 2A to forward the packets to. So it's going to choose AS1, AS3, and X, this other AS path, which is actually longer than this other one to pass the data. This is also very well known as the hot potato routing. Allow me to explain. So 2D is this guy holding a hot potato. So the packets are almost like these hot potatoes. And 2D can't wait to get rid of these packets. So 2D wants to be able to pass the hot potatoes, the packets, as soon as possible. Therefore, picking this poor guy here, 2A, to throw all the hot potatoes over. Distance is shorter. All right, so that takes us to quiz 49. So once again, the poly stressed that only the gateway routers does the pass selection, all right, the AS pass selection. What happens at 2D there in the video is that it's an internal router. But in case there are multiple AS pass selected by the gateway routers, and these are multiple gateway routers, then the internal routers will need to select which gateway, okay? So the internal routers does not do AS pass selection, all right? Good. Now let's start quiz 49. Okay, good. So quiz 49 here, you see that the scenario is pretty much the same. All right, so 49. Except that Poly has added a link between 2A and 2B. And the link cost is 27. All right. Right, so 2D here is the sender still. It needs to send data to destination X, just like what the video says. And 2D learns through IBGP. Yeah, there are routes to X through either this gateway router or this gateway router. Okay, so question. Q1 ask, which router would 2D send the data to next? So I'm not asking which of the gateway routers 2D will send data to. Because for the internal router, it needs to call the intra-AS routing, right? Let's assume that the AS2 here runs the shortest path routing, such as OSPF. Then which router, which immediate router would 2D send the data to next? Okay? And Q2 asks, which AS will be the next hub in terms of AS hub? Which AS would the data go next? So once it goes outside of AS2, which AS would it go next towards destination X? All right, good. Now let's go to the score space. Guys, there's a slight glitch with the score for me today. So guys, the quiz pick might not show, but guys, feel free to start working on it and answer the question. And this one is somewhat straightforward. How about just 2 minutes? Okay, let's start counting time. see. Team 1, 2B and AS1. Let's see. So which one is on the shorter path, 2A or 2C? If we are going for the shortest path routing, right? What is the shortest path from 2D to 2A? We have one path direct, that is 201. We have another path going 2D, 2B, and 2A. This is 179. So this one seems shorter, right? There's another one, 263, 112, and then 27. This is obviously longer. I guess all these are just longer, and this one is longer. So obviously the shortest path potentially is discovered here, right? Good. So 2D will send to 2B first, right? And 2B, following the shortest path algorithm, will send to 2A. So you know what, Team 1, you're correct. The next router to forward the data to is 2B. And so the data will go to 2A. Therefore, after exiting AS2, what is the next AS to go to? AS1. And then 1C here will then forward the packet to 3A. 3A will forward the packet to 3D. And 3D finally forward the packet to X. Okay, so that's how intra-AS and inter-AS forwarding is done. Good. So this type of routing is called the hot potato routing, because 2A, 2C, having AS paths, they are kind of holding the hot potato. Okay, and well, actually 2D here, knowing two paths, these are hot potatoes, and so 2D would just need to throw the hot potato to whichever is closer. Okay, so let's see, Team 13. Yeah, there's a lower cost from 2B to reach 2A, so send data to 2B. And 2A's BGP router goes through AS1 to AS3 and then X. Very good. 2B and AS1 to 2B and AS1. Let's see, Team 2. We'll send the data to 2B. The cost to 2D, the cost from 2D to 2A via 2B is the lower one. It sends to 2B, it will send it to 2A. 2A then forward it to, very good. Yeah, it goes all the way, 2B to 2A. And next AS hop is AS1. All right, 2D will be the data to 2B, 2D will send the data to 2B first and then 2A, and then follow the AS path. And the next one after leaving AS2 is AS1. All right, good, very good. Yeah, there are other teams trying to fill up the answer. That is okay. Let's come back to the lecture. Good. Now you see exactly how the forwarding is done across the two levels. All right. The one last technical video about BGP is that there are a few message formats defined in BGP. To be exact, 4 types, and one of them is used for the AS path advertisements. So pay attention, because towards the end of the video, there's going to be a pop-up quiz, okay, on the live channel asking you, hey, for this data, which type of messages is sent?
This is the last slide of the BGP protocol. Okay, so in BGP, the protocol, it actually defines 4 types of messages. Okay, so not just the message we mentioned earlier containing the path vector being passed in the BGP sessions. Okay. There are other types of messages that BGP sends. So some of them are actually to send the path advertisements, to send the path vectors, but some of them are to establish the TCP connections, okay, for the session, or to tear down the TCP connection, or to keep the TCP sessions alive. Okay, let's go through these BGP messages. The first type is called the open message. Yeah, the first purpose of it is to establish the TCP connection. Okay, so the sending peer there will be sending an open message to the receiving peer. Okay. Receiving peer will be sending back an ACK for that message. As a result, the two peers establish a BGP session. So the ACK of the open message there is going to be in the keep alive message format. Okay, I know it's a bit tricky. Now, the open message is also used to do the authentication. Okay, so the two peers can authenticate each other to make sure that the past advertisements, okay, are indeed the true paths, okay, to be discovered. Now, update message. So this is the message being used to send the past advertisements, the past vectors. So this message is also allowing the routers to withdraw outdated past vectors. Keep alive message we saw earlier, it's to ACK the open message to establish a TCP connection. Keep alive message is also being sent, okay, periodically to refresh the TCP connection, just in case there's no update messages being generated. So update messages is the past advertisements. Last is the notification message. Okay, so this reports in case there's any error in the previous message. Okay, and it's also used to close the connections for peers.
All right, so that is the 4 types of messages. Now, on the live chat, guys, you see, I'm asking which BGP message is used to withdraw a route advertisement. All right, so it's not to send advertisement, but to withdraw. Which one? Oh, I see, Josephine. Okay, yeah. The update message is used to send the route advertisements as well as to send the withdrawal of the routes as well. Very good. All right. Very good. Yeah, that is kind of straightforward. Good. Now we can move on to the next topic. This is the biggest topic in BGP. It's called the BGP routing policy. Okay, so in this video, it's slightly long, almost 7 minutes. But in the video, you will see that, hey, the route selection has a lot to do with the policy. And nowadays, the world is flat and the world is actually really controlled by economy, money. You will see that whether it's ISPs or a customer like us subscribing services from ISP, what we don't like doing is to forward data for other people that we do not receive any benefit from. Recall, in order to access the internet, right? In order to receive emails, to send emails, or to be able to play an online game, you need to pay your ISP. And ISP receiving the money, then happy to forward the traffic for you. All right? So you see, access is something that's general. Traffic can go either way. To access the internet, to be able to connect it to the internet, you will need to pay someone. All right, good. So in this video, there'll be 2 cases. You will see that the ISPs will not be happy to pass traffic for other people, for other ISP and their customers. And you as a customer will not be happy to pass traffic for the other ISPs. All right, so slightly long, but right after this video, we'll go through a series of quizzes from 50 to 53 to make sure that you're familiar with the notion that BGP routing policy is very much money dependent.
One very important issue about BGP to discuss here is, BGP routing is very policy-based these days. If you recall, there's import policy, there's export policy, there's also local preference for route selection. There are lots of things the network admins can tweak, okay, to decide where packet goes. The reason for those policy-based setting is this. Let me use an example to explain. Consider this network. We have three ISPs in the middle, A, B, C. They are the provider networks. W, X, Y are the customer networks. More specifically, W is the customer of ISP A. So W pays A some amount of money every month, and A will in turn help W passing packets, okay, going out to the rest of the internet or coming in from the internet. Similarly, if the traffic is supposed to go out the other direction, all right? So W pays A, and therefore A is responsible to serve W. Similarly, for this customer-provider pair, Y being a customer, C being a provider, X being a customer, B being a provider. Now, X is a little bit more complicated. It's multi-homed, okay, customer network. So X here pays B and C, okay? As a result, B and C should both be forwarding packets for X. In scenario 1, let's assume that there's a user in customer network Y here wanting to send something to the user in W. And so in order for W to draw in traffic from the internet, its provider A here will need to announce its existence. So AW here, okay, an AS pass needs to be sent to the neighboring ASs, which happen to be ISP B and ISP C. Okay, so A advertises pass AW to B and to C. As a result, okay, B is going to see this pass, okay, and prepend itself, okay, and see if this AS pass needs to be further advertised to yet another neighboring AS, such as provider C. Now, B's network admin actually knows better and chooses not to do that. And the reason for that is because of this. If BAW is advertised to C, C is going to discover, this is actually one way for this user in Y to send traffic to user in W. And therefore, the traffic is going to go this way to W. And you know what? B here, okay, B does have a customer X. X is paying B. But is W paying B? Is A paying B? Is C paying B? Well, based on the setup of the problem, WAC not paying B, and yet B is using the network resource here to transit the traffic for B and C. Okay, so B gets no revenue to do this route, BCAW, because CAW, based on the scenario setup, not paying B. Okay, so chooses not to advertise BAW to C is so that C does not discover this pass, and therefore, okay, not using this pass to send traffic. Instead, C here receiving AW is going to prepend itself CAW, and Y is going to use CAW as a way to send traffic to the user in W. So you see in this scenario, very obvious. For a customer network, ISP will be happy to route traffic to and from the customer. Okay. But the ISP not getting paid by others would hate to transit traffic between these other ISPs. Okay. So bottom line, not getting paid for the work. Scenario 2 is very similar to scenario 1. The network is completely the same, and we just continue scenario 1 from here. When B has discovered BAW is a pass to go from B to W. Now back in scenario 1, a min of B chooses to not forward BAW to C, okay, so that we don't draw traffic this way. Nice. But B will actually have to send BAW to X, so X can discover XBAW is a pass. So just in case there's any user in X wanting to send data to user in W. Nice, so makes sense. But hey, X is dual home, so there's yet another connection to a neighboring ASC. So should the network admin of X here send XBAW to C? Well, let's assume that we send XBAW to C. In this case, C is going to discover CXBAW is a pass to send data to W. Similarly, y is going to discover y, cx, baw is a path to send traffic. Y, cx, baw is a path to send traffic from a user in y to a user in w. And that's going to travel like this. How do you like this? Well, from an access network admin's point of view, hey, this traffic is actually not for me at all, right? It's actually between y and w. Y pays C, W pays A, and no one is paying me, and yet I'm paying B and C. Okay, so it's a big no-no for X here to send X, B, A, W to C. All right, so X will not want traffic coming from C and simply transiting to B. So X should not be advertising anything to C, okay, coming from B. So again, money is the issue. So X is not getting any money from C or from B. Therefore, X is not happy transiting traffic for these other ISPs or even from other customer networks not paying. Okay.
All right, so yeah, in the second case, think of yourself as a customer and you subscribe to the online access. A lot of times in your contract is that, hey, it's guaranteed that every month you get how many gigabytes of traffic. In case you exceed that amount of traffic, then the speed, the downloading speed is going to be lowered, right? So if you transit traffic for other customers, then the chance is high that you're paying for the other customers, and in the end, at the end of the month, you need to suffer transmitting traffic in a lower speed. So you see, that's the point. Good. Now let's move on to the quiz series. The first one is quiz 50. Okay. You see that it looks similar, but it's not exactly the same. Okay, so this is quiz 50. Let's go to the whiteboard mode. So you see that there are still 3 providers, but this time there's no link between B and C. All right, good. W, X, and Y are the customers, okay, and A, B, C are the providers. Now in this quiz series, Y very often send data to X. Y very often needs to send data to X. Now, the basic condition is this. So X here, okay, is the customer, and X pays B. That makes X the customer of B, and B is the provider. Okay, so in turn, B will be responsible for forwarding traffic both this way and this way. Okay, so uplink from X or downlink to X. Q1 here asks, should B advertise the AS pass AX to A? Okay, so you see that when A starts up, A will announce its existence to B, and B will prepend itself and resulting in AS pass BX. And BX will need to forward such an AS pass further, supposedly. Okay, so should B advertise the AS pass BX to A? Okay, and what's more important is to tell why. Should A advertise the AS pass ABX to C? So you see that in case B decides to pass BX to A will prepend itself, right? And this is the new AS pass to a destination X. And this A here would then try to forward that to the neighboring AS. And should A here pass ABX? Oops. Should A here pass ABX to C? Okay, what do you think? All right. And what's more important? Tell why. Good. Let's go to the Discord space, channel quiz 50. Oh, I see Team 15 already typed something up. Very good. I see. Yes and no. Okay, very interesting. Guys, You see, this is very free quiz. Unlike the previous quiz that are more calculative, it's policy based. So what is your policy, essentially what I'm asking, okay? So it can be very subjective. Guys, this one is straightforward. As I see Team 6 also typed something up. So how about 3 minutes, guys? Discuss with your teammates what you think. Okay, let's start counting time. So maybe interrupt here. Guys, as we said, the scenario is that Y very often send data to X. That means that X is looking for data coming from Y. So would X be happy if Y wouldn't be able to send data over? Yeah, guys, very good to see your opinion. All right. So again, as I said, policy is definitely very perspective dependent. And I'm very happy to know that Team 5, 6, 9, 20, etc. Many of you guys pay attention to the videos. If a domain does not get payments, usually they don't forward traffic. And as a result, Team 15 says, for Q1, yes, because B would definitely like to be able to forward traffic to X. And so B will need to announce X's existence outside. Okay, but you see, A here sees that the eventual destination is X, and X is not my customer. Okay, so unless B pays A, otherwise A will refuse to advertise ABX to C. Okay, makes sense. Makes sense. And so this is probably the first thing A does to force B to negotiate with A and come up with the deal to transit traffic to Y. Okay, so hey guys, if you say no for Q2, it's not wrong at all. This is very likely the case at the beginning. Okay, so similarly, Team 6 says the same. No, A won't do anything because A obviously does not get revenue, right? Unless B pays A. So essentially, this is a way to enforce B to strike a deal with A. Good. Revised, okay. Sorry, I thought if I influence your call, Kelvin. Yeah. Yeah. So, but you see, the whole process will take some time it will take some time, yeah, for every party to discover that setting up a contract is necessary. Yeah, X will pay A. Otherwise, so maybe X will pay A. So maybe X will pay B and B will pay A in return, right, to serve X. Yeah. Good. So I think Team 10 here, Team 10 might be hearing what I said in the middle. And the reason is this, it's very often X needs to receive data from Y. And so if A does not forward ABX to C, Y won't be able to send data to X, right? So probably C pays A. Yeah. C will need to pay A further to get this to work, or B pays A to get this to work. I think either way will be fine. So Team 10 here stands out in a way that it's Team 10 is thinking that maybe C pays A. And I was thinking maybe A not forwarding ABX to C as a way to enforce B to negotiate with A, or B to pay A. Let's see what Team 13 says. Yes, it should. Yeah, obviously B should forward BX, right? X is the customer. X pays B. B is obligated to. So Q1 answer is yes for sure. Q2, eventually you think if Y needs to send data to X very often, yes. But how do you enforce that? So ask B or ask A to pay, ask C to pay. All right. So let's see what Team 13 says. The pass doesn't help the customer of A or receive traffic, obviously, right? A is so innocent. But that doesn't mean it won't affect my other customer. Interesting. Control will send other providers through non-optimum paths, which is not optimum for congestion control. Okay. So 13 is thinking on behalf of the entire internet. Yeah, so for example, W there could be sending traffic somewhere where traffic is very concentrated. So W is A's customer, and W might complain even though it's not A's fault. Make the user from Y quite unhappy, and our customer experience is top priority. Yeah, so W might as a result be a less happy customer. Good. All right, so Team 13. Very good, very interesting perspective. The reason is slightly different, right? And Team 10 here is saying that maybe C can pay A. And Polly has proposed maybe B can pay A. Good. So should or should not, it depends on your perspective. Those who say no, obviously, makes sense because that's what the video said, okay, previously. Now let's move on to the next scenario, which is slightly more complicated. Let's see here. So this is quiz 51. Let's go to quiz 51. There. Okay. So in 51, you see that the network looks a little bit different. Okay, it's now back to the network that we show in the video. So it's cyclic now. So A, B, C are well connected. All right. And we know for sure, hey, as you guys answered in quiz 50, B should definitely advertise BX. So BX here will be forwarded to A. And you know what? This is a cyclic network. So there's another pass here. To C. hey, wait a minute, there are options now. All right. So what I'm trying to say here is that the links you're seeing, this is the direction, this is how the traffic flow. Let me add something else. Okay, the money flow. Let's suppose here, B, in order to make X a happy customer, then we'll negotiate with A and C, right? And the deal is that B says, hey, A, I'll pay you this amount, which is thin, that means pays less. And the contract with C, unfortunately, is more expensive. So you see the air is thicker. Okay, so the brown arrow indicates the money flow. So Q1 says, A and C, in case charges B equal amount. So Q1 is in the scenario where the two airs are equal thickness. Okay, so B pays A and C equal amount of money to forward data. All right. Suppose now you're hired by B. Should B advertise BX to only A, only C, both, or at least one of the two? Okay, so you have a choice to make. Pass only to A, only to C, to both of them, or hey, I don't care, at least one of A or C. Okay, but what's more important is to tell why. Justify your choice. Now Q2 is finally what I was indicating with the brown arrow. Okay, so C charges B more, thicker arrow here. And A charges B less, thinner arrow here. In this scenario, suppose you're hired by B. Would you advertise BX? Again, only to A, or only to C, or both of them, or at least one of them? Okay, tell why. All right, so let's go to the Discord space, quiz 51. I see some of you guys have already typed up some answers. Guys, how about 4 minutes? This one is slightly less straightforward. Okay, so 4 minutes. Yeah, I see, guys. For quiz 51, I guess the class this time is less controversial. Okay, you guys actually are following the videos closely. So I see. It seems quite straightforward for you guys. For Q1, because you pay equally, right, to to A and C. So yeah, send them both. Yeah, because they are supposed to serve you. But in case C charges more and A charges less, then you forward only to A because then you pay less. Right? So this is both to optimize the expense. So Team 6's answer is very straightforward and get to the point. Okay, both since A, C charges B equally. And then for Q2, yeah, definitely only to A because A is cheaper. Yeah, I think that's generally the case, right? This time. Yeah, only to A. Both and only to A. Yeah. Anyone dares to take a different stand? All right, guys, it's about time. So almost 4 minutes. And you know what? While I think Team 1, 2, and 20 are typing up their solutions, I think chances high that the solution looks similar. Okay, surprise me. Let's see. Very interesting. Very interesting. All right, good. Team 1, guys, look at what Team 1 says. Team 1 actually says, in case A and C charges B equally, B forwards BX only to C. Yeah, because at this point, there's no need of traffic going to or from W. Yeah. And you know what? B going to C, if Y sends data straightforward to X, that seems to be a shorter route and the charge is the same. Yeah. Unique answer. Cool, cool. But on the other hand, right, so the other teams, if you send to both and C, then in case the W begins to need to send data to X, then there's a path readily available. Okay, let's see what Team 2 says. Since we are paying equally, we should ensure our customers are able to forward to A and C. Hence, B should send to both A and C, and only to A because money is important. Definitely, you get the message. Very good. And I would choose C since we know Y often send to X, so C is the only pass. Very good. Very good, Calvin. And I would choose A because C charges more to save money. Maybe you need to choose both. You mean Q1? Or does anyone say that for Q2 you still advertise to both? Yeah. So I know this quiz gets a little bit gets a little bit open. So there are arguments that you can come up with arguing one way or another. So Team 20 here argue for C. Good. And you know what, guys? There are 2 more quizzes coming, but it's now time to take a break. So it's 11, 12. Okay, while you guys working on 50, 51, and you know what? The questions for 52 and 53 are already available. If you go to those channels on the score, you can see them. You can take a peek ahead of time. But let's still take a break. It's 11, 12. Let's resume the lecture 11, 22. Okay, let's take a break. Yeah, it's time. Okay, let's come back. And the next quiz is 52. All right, so this is the cycle network scenario. Okay, yeah, 52. Whiteboard mode. This is the cycle network scenario. And this time, let's say C advertising. Okay, C is trying to advertise ASPass, and these are the ASPass that he's looking to advertise. So let's assume that B earlier decides to advertise BX to A and C. And A decides to advertise ABX to C. So C now then knows two paths to X, that is CBX and CABX, right? So BX here announced to A, so ABX here can be announced to C, and BX can be announced to C as well. So now C knows that there are two paths, okay, from X to anyone else, all right? So C, in this case, charges A more. So where is my, yeah. So C charges A more. So money flow, let me show that. C now charges A, and more than C charges B. All right, good. Suppose now you're not hired by B, but hired by C. Oh, now you're hired by this company, this ISP. Okay, would you advertise CABX or CBX or both to Y? Okay, tell me why. All right, so I see already several teams go on and read the picture of quiz 52. But some of you might still need time. So how about that I give just 2 minutes, okay? And we'll come back to check out everyone's answer. Yeah, so in this case, right, I see that certain teams are still going for the money, but that is exactly the point I was trying to make in the video. Yeah, so this is perfectly fine. So C will obviously choose to advertise CBX because C charges CBX. Oh, wait. I think there's a certain confusion here, guys. Guys. Okay, team 6. C should advertise CBX only because forwarding through B costs less than through A. C is a magical company. I don't know if you guys have observed. C is actually charging A and B to forward traffic. For why? So C charges A more than C charges B. If you're going for money, hey, you should C should forward pass ABX, CABX to Y, because that way the traffic from Y to X will always go through A and C will profit the most. Okay, so by the way, forwarding traffic through B does not cost less for C. Rather it costs more because you are gaining less from B. Okay, guys, do you see? Costs less to forward data via B, and sending data through B profits both A and B. Yeah, I think there's probably some sort of confusion here. Guys, do you understand what Polly is saying? Yeah, sorry, I was not seeing this. Yeah, many of you say that you send CABX. It charges a... okay. Team 1. Team 1 is then correct. Choosing CABX because C charges A more, and this is the right way to earn more money for higher profit. Very good. Guys, do you see? CBX, B charges C less. B pays C less. You see that the money direction indicates how money flows. But I can understand, guys, you are confused because C seems to be a company that's just charging everyone. You know what? C is a magical company. The way internet works, or the way how one pays another on the internet, is whether you dominate the market. Okay, so C is a magical company. In case C charges everyone, that means C is probably the oldest company, the company that has the biggest market share. Okay, and everyone tries to connect to C. Then C does have the position to demand money from these other guys. Okay, just like X, Y, and W as customers, I'm small domain. I need to pay someone bigger, having more access, having wider access to the internet. Okay, so team 6, team 9, 10, 20. Yeah, be careful. Okay, team 2, you got it. Very good. All right. Yeah, so you guys probably see my mark, and I kind of misled the answers coming ahead. Sorry about that. Okay. Anthony fixed, team 9 fixed that. Yeah, Devon, team 10, sorry to misled. And 20, slightly preferred. Yeah, sorry, Calvin, for misled, for misleading you. Okay, all right, this is now the right answer. Yeah, very good. Great. Okay, so just team 9 and team 20. Oh, yeah, just make sure that you fix. And I think team 6, right? 6, have you changed? Not yet. Okay, good. All right, and team 13 and 15 here are saying both. Yeah, because they felt that redundancy helps. Okay, so for these two teams, the answer is perfectly fine. You probably don't mind paying, you probably don't mind advertising both because you're making a profit from both A and B anyway. Okay, just more or less. And providing two paths adds extra user experience. All right, good. And now the last, quiz 53. Okay, let's go to again. Yeah, the PowerPoint mode. And yeah, so from this quiz, then you see it's really a money game. Okay. And you see also that A might be in trouble, okay, as an ISP, okay. And so what we need to do here is to continue from the two quizzes above, okay. So in the last quiz, we see that A pays C more and B pays C less to forward traffic. But from the one quiz before, right, A charges B, but less than how C charges B to forward traffic. So the total, okay, money flow is now like this. Okay, and you see here, okay, consider money. If CABX, this is the route, okay, to forward traffic Y to X. Suppose now you are hired by A. What would you do to make your stockholder or your boss happier? Would you raise or lower the price charging B? So A here, would you like to charge B more to forward traffic for X? Would you like to raise or lower the price charging C? Okay, A pays C a lot. Okay, would you like to lower this or raise this? Okay, so again, tell why. Now, you can look at it strictly from the economic point of view, but you can also think of what's the best for your customer, okay? And Q3, can you think of other solutions? Okay, instead of playing the money game, are there other things you can play as the admin working for A to ease the situation here, all right? So this one is a little bit challenging, especially for Q3. So how about 5 minutes? Okay, so let's start counting time. And please go to the score space, quiz 53. Yeah, I guess we've come down to a few solutions. Okay, very, very interesting, guys. And you probably want to hear other team solution. So for Q1 and Q2, I see generally that you guys say that, hey, A should raise the price charging B. And for Q2, A should lower the price paying C. Okay. But for the longer term solution, guys, check out Team 15 solution. Team 15 is saying that maybe A should stop advertising ABX to C. Yeah, then the traffic will not go from Y to X anymore. And as a way to get B and C to sit down and talk to A. All right. Very interesting. Okay, so this is more a engineering, a force kind of solution. And you probably heard Polly mentioning that in quiz 50, right? So you guys say that, hey, maybe A should not for BX to anyone because A obviously, X is not a customer of A, and B does not pay A originally, right? In quiz 50 setup. But you heard Polly mentioning that A, and that is a way to also get B to start paying A. So why not just don't advertise ABX to C? That will get C to start talking to A, and B might also want to talk to A. Hey, how come the traffic is not coming, right? And Team 6 is very, very consistent, right? So regenerate a cheaper price bundle with B and C, okay? And maybe it can be free charge for all of them. And maybe we can just, be buddies, and then that's forward traffic for each other for free. And I'm actually not quite sure if that will really work. Free is something that's nice to attract customers, okay? But you see that being free as a service can also be easily abused. Okay, Team 6. Okay, but I think that is actually a once-for-all solution. Yeah, if we can all respect each other and make sure that we moderate the traffic somehow and balance the traffic going out. Team 20. Okay, Team 20 is very funny. Okay, so for Q3, the alternative solution is maybe no alternative solution. Okay, because if then that would not be economy, right? So it's all about maximizing the revenue. Yeah, Kelvin, very interesting, very alternative thinking. So if you stick to economic incentives, maybe there's no better way. And Team 13, yeah, 13 here is trying to recall exactly who pays who more. Yeah, but Q1 is still, right, increasing the charge, and then lower payment to C. Okay. And the solution of Team 13 is very, very good. And this is probably the ultimate solution. The reason that A suffers, A gets paid less from B, and A gets paid more from C is probably because A's business is not big enough for B and C to dare charge us more or less. Yeah. So the priority is to get A to get bigger, to get more customers to pay A. So there are more of these W's, then B and C will be then happier to talk and respect a little bit more of A's position, right? Very well done, Team 13. Okay. Louise, I thought you were very engineering aptitude, but you turned out might do very well in the business school as well. This is very insightful. Running a business in a way, and running an ISP is a business. Okay, it's just that the route configuration nowadays is very, very depending on the business of the ISPs. Team 1 says consider priority is to make money in the long term. Yeah, so Team 1 is saying that why don't we sit down and talk, right? Yeah, but I guess we see already several teams saying that sit down and talk. But the thing is that to be effective, okay, in the negotiation table is so that you have, something precious the other side needs, okay? To strike a deal, you give some, and therefore the other end also gives something back. And so you gotta have more to give, right? Then you negotiate a better deal. So Team 10, yeah, Team 10 is also going hey, maybe we should just not advertise CABX. So Team 10 solution is very similar to I think 15, right? Yeah, 15. So in a way, you hold something that's choking the communication. That's also something that you can bring up to the table to negotiate. And Team 2. Yeah, so Team 2's approach is, ABC, again, sit down and talk. Let's hope for a loving world. I think it's very similar to Team 6, right? Yeah, maybe eventually no charge for each other. Or maybe a fixed charge for a few years and then renegotiation after a few years. Okay, so that would avoid needing to negotiate again and again. And Team 9, making advertisement targeting X and Y, thus profit from Y greater than X. Okay, sounds interesting, but Anthony, I'm not quite sure if I get this. Could you elaborate a little bit more? This seems to be interesting. All right, so, okay, so Team 19, if we are the only gaming town, what B and C pay you for expand traffic and just enough. Okay. Yeah, okay. So this is like, slowly increasing or decreasing until they realize it. That is a very, very interesting strategy, business-wise. Again, a unique answer. Very good. Okay, guys. I hope that by now, up to quiz 52, you see clearly that the internet routes, the policy, are very money-driven these days. Okay, and some of these policy are sort of national consideration driven these days as well. All right, so now we can bring up the summary video. So this is BGP.
Now the summary slide. So internet routing is hierarchical. At the lower level, intra-AS routing. At the higher level, inter-AS routing. Now there are three very good reasons for such separation. Okay? Because at the higher level, the network admin would really like to be able to block transit traffic. So doing policy-based routing allows admins to do things flexibly. In the intra-AS, however, then we can go entirely with the performance. Let's calculate strictly the shortest path so that the delay to go from one router to another router will be the lowest. Third reason, separating internet routing to two levels is also to reduce the amount of memory requirement and to reduce the network bandwidth consumption. You see, intra-AS running link state there, the amount of global information much lower, right? Because you're only keeping the information of the local area network. Amount of link state reports you need to send also lower because the number of routers in the AS lower. Similarly, in the backbone, these border routers, the amount of it lower. Therefore, amount of updates we need to send lower. And there's prefix for the destination. The higher we can aggregate the prefix, the memory requirement for the path factor also lower. So, separations of internet routing into two levels.
Okay, so very important you pick this up. Intra-AS routing, we go with shortest path performance. Inter-AS routing, now you see, it's a little bit chaotic. Okay, we go with the policy. So when we say policy, that usually meant that we do whatever the best we can do money-wise, right? Good. Now, time to move on to the next chapter. This is chapter 6, the link layer protocols. So this first video introduces the major functions of a link layer protocol. All right, chapter 6, this is the chapter about link layer protocols. And some of these link layer protocols might be used by one of these things called the local area network technologies. So, hey, link layer talks about link. A number of these hosts or routers connected to the link, the area it covers is very small, hence the name, local area networks. And we'll try to learn the principles running behind these link layer services. The first is how error detection and correction is done at the link layer, and how we do multiple access control. These are called the MAC protocols. So there are about multiple hosts or routers accessing a shared broadcast channel, broadcast link. So in such a situation, when these hosts send data at the same time, these data might collide to each other, and we ended up having useless data. So one needs to be careful about multiple hosts accessing a shared broadcast channel. You'll also hear about another set of addresses we use for the link layer hosts, link layer nodes. So these, a combination of these, might be selected and implemented in one of these local area network technologies, such as Ethernet, such as VLANs. Let's start from the terms. Hosts and routers on the internet are now all called the nodes, and these nodes are connected by the links. These links can be one point to another, a wired link, or a shared broadcast medium such as a wireless link or a LAN. Now, packets at this layer, link layer, or layer 2 are called the frames. Okay, so they are the packet that further encapsulates a datagram. A datagram is how we call a packet in layer 3, right, in the network layer. So in essence, in the data link layer, what we do is to transfer datagram from one node to another node over a link. And these nodes are physically adjacent, close by. So what's interesting about link layer is this. When a packet, a datagram, travels through the internet from a source to a destination, we travel through multiple links. And each of these links could be running a different link protocol or link layer technology. So for example here, we could have a packet travel through Ethernet for the first link, and frame relay for the second link, and Wi-Fi, the last link. Now, each of these link layer protocol might provide different levels of services. So they could be doing reliable data transfer or not. They could be doing multiple access control or not. So here I'm using an analogy, okay, transporting people to compare transporting packets over the internet. So let's suppose we are taking a trip from Princeton to Lausanne, the source and destination. What might happen is this: you take a taxi from Princeton to JFK, the airport, and then you take a plane from JFK to Geneva airport. And then from Geneva, you take a train to Lausanne. Right? So the tourists here, the people we're transporting, will be just like the datagram we're sending over the internet. And each segment is a communication link on the internet. And the transportation mode is a different link layer protocol. And the travel agent is the one doing the routing, okay, coming up with this plan or this route. All right, so essentially, to send data from one end to another, you use a path. And along the path, you could use very different links and an interesting combination of links. All right. Okay. Now, the second video talks about the service implementation. The first half will be still a walkthrough of these basic functions. But in the second half, you will see a little bit of where link layer protocols are implemented in the operating stack. Now let's go over the link layer services or link layer functions quickly. First are these, framing and link access. These two are the necessary functions, so you see this in every LAN technologies. So framing is about encapsulating datagrams into frames, and this is done by adding packet headers. In link layer, you begin to see some protocols add also packet trailer, so we add control bytes after the data. Now, in case the link is a shared medium, then we need to do this channel access control to avoid collisions. And we need to introduce a set of addresses, which is often called the MAC addresses. So they'll be in the frame headers to indicate who the source host or the destination nodes are. By the way, these MAC addresses are very different from the IP addresses we've seen in chapter 4 and 5. Second function is reliable delivery. This is a function that's sometimes not necessary, but sometimes necessary. And it depends on the kind of link, okay, we're using. If the link is a low bit error link, such as fiber links or twisted pair, generally wired links, we don't see many bit errors. We could let the transport layer protocol, such as TCP, handle those rare bit errors. But for wireless links, we could see potentially high bit errors. Then you might want to implement it again in the link layer. Now, but why? Right? Because TCP can handle it anyway. Third is flow control. This is to pace the sending rate so that the sending node will not be overwhelming the receiving node. Fourth and the fifth functions are related. One is to detect error. The other is to further correct the errors. Now you can imagine for certain links, you definitely want to do error detection. For certain links, you might want to do error correction. And last is called half duplex and full duplex. So this is related to how the bits are modulated on the link. For a half duplex link, nodes can send over the link in both directions, but not at the same time. For a full duplex link, then you can imagine data can be sent in either direction at the same time. Where is the link layer implemented? It's definitely in each and every host, but particularly here at the network adapter. These network adapters used to be big, looking almost like a graphics card. They are also called the network interface cards, the NICs. But nowadays, they are more, very small, tiny as chipsets on the motherboard. That's why if you look at your motherboard spec, you might see an Ethernet chipset or a Wi-Fi chipset on it. And these network adapters are where the link layer and the physical layer protocols are implemented. And the network adapters are attached to a host through the system buses. This is illustrated here. This is your system, and this is the system bus. We have CPU and memory attached to it, and there are also peripherals attached to the system bus. And the important peripheral we're talking about today is the network adapter. And this is where the link layer and the physical layer protocols are implemented. Now, part of this link layer protocol will be running on the CPU as part of the operating system that will enable the processes running on the CPU to call such that the network adapter there will be able to send packet out on the internet. Okay. So, network adapters, there are combinations of hardware and software design. And very often now, part of the hardware design will be implemented as firmware, such that occasionally the company can send you a firmware update so you could revise the hardware design. Now, One of the example is the MAC address. Several network adapters manufacturers implement the MAC address as firmware, so one can potentially override the MAC address. So this slide illustrates the adapters communication. So on the left is the sending adapter, on the right is the receiving adapter. You see operating system running here. There might be a process generating some data, so that through the network layer, we have datagram coming down to the link layer running on the network adapter. We would do what? We encapsulate the datagram into a frame by adding some headers or trailers. Okay, so the blue bits here. So this will travel through the internet at the receiving side. Yeah, the link layer at the receiving side will extract the headers and trailers and examine to make sure that these functions are running, and then extract the datagram and pass it up to the higher layer. All right, so that's a link layer. And from what you heard, it's very similar. The functions are very similar to the functions we've seen before in the transport layer, right? So in transport layer, we talk about a logical communication between one machine to another. But this time, it's a physical connection from one machine to another. And so you can imagine error detection, error correction, flow control. These functions are general, as long as it's one end to another end communication. What's a little bit interesting in link layer is that, for example, the wireless link, it's a shared medium, meaning that if there are multiple devices on the shared media, shared link, there could be some collisions as you send data to each other, and there's some coordination that needs to be done. Okay, but unfortunately, those interesting mechanisms to try to coordinate devices on shared medium, we don't have time to talk about this semester. Okay, but I do have those mechanisms recorded as short videos on the video page. All right. So if you're interested, definitely go there. But with that said, and given the time we have, yeah, it's time to close the lectures for the semester. And I would like to use the time to come back to here. Yeah. So for this week, know that we don't have time to go on with the video that talks about error detection and potentially error correction schemes. So quiz 45, we'll just streak that from the planned list of quizzes to submit. So for this Saturday, all you need to do is to submit the solution from quiz 49 to 53. Okay. And for exam 1, we know better the scope. Sorry, for exam 3, of course. We know the scope should be P8 to 9 and chapter 4 and chapter 5.1 to 5.4. We'll also skip chapter 6 because we cover very little, just the overview, introduction of chapter 6. Okay, and so what remains is just that good luck with the exam coming Wednesday. Poly will be online next Tuesday in case you have questions during the lecture hour. And with that said, I say goodbye for the semester. Oh wait, I will see you next week. Okay, so goodbye for all the lectures. Okay, bye. See you next week for the exam. Okay, bye. Yeah, it is the last class. Yeah, time flies in a good way and in a bad way. Yeah, bye. Yeah, I hope you enjoy the quiz 50 to 53. Yeah, it's a little bit tricky. And if we don't go through the series of quizzes, it's a little bit hard to communicate that the internet routing at the inter-AS level is tricky. All right, bye. Thank you all for your participation. Because the class is not going to be possible without you guys interacting with Poly, right? And I see, and you see also that with openly sharing your solution, your thoughts, it helps other teams. Just like how you get some ideas that are different from the other teams. Okay, good. Yeah, thank you. Thank you, Luis. Thank you, every one of you. Each and every one of you. All right. And next week, take it easy. Take it easy. Polly promises you that the exam is not going to be tough. All right. And all you need to do is try your best. Okay? Bye. Oh, thank you. Okay, bye. Oh, Luis. I'm gonna miss you. You're very critical. I see you're a good engineer, but today I see the potential of you doing well in business school, Luis. Okay, good for you. Alright. Yeah, be careful choosing your partners, though. So maybe start your own to begin with. After you get some experience, you get a rough idea, then get to know people. And Luis, I know for sure that you will have no trouble getting to know people. Alright, all the best. Okay, bye. And bye, Ding Xue. Good to see you. Alright, just in time to say goodbye. Okay,